Hello students, myself Maitri Dave and today we are going to discuss about arches. To be specific, we will see the technical terms and the construction of arches in detail. But first of all, let me give you the introduction of an arch tool. So an arch is a structure constructed in a curved shape with the wedge-shaped units either of bricks or stones which are jointed together with the help of mortar and provided at opening to support the weight of the wall above it along with other superimposed loads, right? Because of its shape, the load from the above gets distributed to support, it means to pier or the abutment as shown in this figure. Now, let me give you a clear difference between the lintel and arch first. So, when I talk about the lintel, it is a horizontal member which is placed across an opening like the door and window to bear a load of masonry above them. But while I talk about the arches, it is a curved member of the wedge-shaped building units provided to bear load above. When I talk about the simplicity and ease of constructions, lintels are there because in the arches we required spatial centering and the form work. So I can say for smaller spans we should go for the lintels, but when it is of longer span we have to go for the arches. Generally, these kind of lintels are used in the buildings, while in the bridges where the large spans are there, we go for the arches. So when we talk about the lintels, it carries less load compared to an arch, but the arch carries high load compared to the lintel. Lintels require rigid surface for resting, while arches can rest on light support also. Here you can see a clear difference through this image, how it is a horizontal member and how it is a curved member. Now let us understand all the technical terms of an arch first. So here the first is the intrados. So the inner curve of an arch is called as an intrados. Here you can see this from this image. Next is the extrados. So the outer curve of an arch is termed as the extrados as shown in this figure. Next is the soffit. So the inner surface of an arch is called the soffit. So soffit and intrados are used synonymously as shown in this figure. Fourth one is the washers. So the wedge-shaped unit of masonry which are forming an arch is called the washers as shown in this figure. Fifth one is the crown. So the highest part or peak point of the extrados is called as the crown as shown in this figure. Next is the keystone. So the wedge-shaped unit which is fixed at the crown of the arch is called the keystone. Here you can see in this image it is a keystone. Next, seventh one is the springing point. So these are the points from which the curve of the arch springs. Next is the springing line. So it is an imaginary line joining the springing points of either ends as shown in this figure. Ninth one is the springel. So it is the first washers at springing level. It is immediately adjacent to the skew back. Now let us talk about the 10th one, which is all about the spreading. If two arches are constructed side by side, then a curved triangular space is formed between the extrados with the base as horizontal line through the crown. This space is called the spandrel, as shown in this figure. 10th one is the skew bed. This is an inclined surface or splayed surface on abutment from which arch curve starts or ends. Here you can get idea through this image. 12th one is the abutment. So this is the end support of an arch. But when I talk about the pier, this is the intermediate supports of an arch. Next is the arcade. So it is a row of arches in a continuation that is known as the arcade. 15th one is the hunch. So the lower half of the arch between the crown and this cubic is called the hunch. 16th one is the ring. So the circular course forming an arch is called as an arch ring, and the arch may be formed by one ring or the combination of rings. 17th one is the impost. So the projecting course is provided on the upper part of a pier or abutment to stress the springing line. This course is called as the impost as shown in this figure. Now, the next one is the bed joint. So, the joints between the washers are called the bed joints, and these bed joints are radiate from center of arch. Next is the center or the striking point of an arch. So, the geometrical point based on which the arc forming intradoors of arch, extradoors of arch, and arch rings are described in the center or as a striking point. 21th is the span. So the clear horizontal distance between the supports or the abutment or the pier is termed as the span of an arch. Next is the rise. So the clear vertical distance between the highest point on the intradoors and the springing line is called as the rise. Next is the depth or the height. So the perpendicular distance between the intradoors of arch to the extradoors of arch is called the depth of an arch or the height of an arch. 23 is the thickness. So this is the breadth of soffit which is measured perpendicular to the front and the back faces of an arch as shown in this figure. So with this we have completed all the technical terms of an arch. Let us start understanding the construction of an arches. So basically construction is divided into three types. First is the installation of centering or the formwork, then laying or casting the actual arch, and lastly striking or removal of the centering or the formwork, right? So let us understand the first step, that is installation of centering or the formwork. So centering is the temporary structure required to support brick, stone or concrete arch during its construction till it has gained sufficient strength. The centering is installed in such a way that its upper surface corresponds with the intradoors of the arch. For minor works, centering may be made of mud masonry constructed to match with the inner soffit of the arch and then plastered. Its masonry is dismantled later when the arches has been constructed and secured. The usual centering is made of timber or steel. Wooden centering is the simplest, or we can say the easiest one, which is used for the construction and easy to dismantle and which is cheapest, or we can say which is good for the moderate span. It is easy and it can be used several times. Now let me talk about the timber centering for wider soffit. So here figure shows a thick wooden plank with horizontal bottom and the upper surface shape to underside of the soffit. Such a plank is known as the center or turning piece. Its width is normally 10 cm and is supported on vertical timber posts called the props with wooden wedges to tighten or loose the centering. If the soffit is wider than 10 cm, two ribs suitably spaced and suitably shaped at the top may be used. These ribs may be connected by 4 by 2 cm wooden sections called leggings. At the end, ribs are supported by bearers, wedges and posts as shown in this figure. Now let me give you idea about centering for wide soffits and the bigger spans. So for wider soffits and for longer spans, built-up centering of cut wood ribs is used. The upper surface of the ribs is given the shape of the soffit of the arch. Here the leggings are nailed across the ribs at close intervals to support the washers at its top. Ribs are kept 25 to 40 mm thick with width varying from 20 to 30 cm. The distance between the ribs depends upon the thickness of the wall supporting the arch. The ribs are connected by braces and struts to strengthen them. Horizontal ties are provided at the lower end of the ribs to prevent them from spreading. The ribs are supported on bearers and a pair of folding wedges is provided at the top of each prop to tighten or loosen the centering as shown in this video. So that's it for the first step. Now let us move to the second step, which is laying or casting the actual arch. So after erection or installation of centering, skew bags are first prepared. Washers are then arranged in proper and required forms, starting from the skew bags and proceeding towards the ground. Finally, the keystone is inserted so that all the washers are locked in position. The washers should be properly bedded. After that, the center or turning piece is eased by slackening the wedges so that it is lowered by a height of 2 to 3 mm. Such a process is an essential requirement in stone arches since it permits the washers to settle upon their beds properly. Now, let me give you idea about the last step, which is striking or removal of centering or deform. So, when the arch has developed sufficient strength, the centering can be removed. No load should be placed on the arch unless the centering has been removed. For smaller span, the removal of centering is done by loosening the folding wedges. But when the span is more than 7 meters, sandbox method can be used for loosening so that shocks are avoided. For this method, we can say a sandbox shown in figure is placed below the prop. Sand is filled in the box with a plugged hole at its bottom. Props rest on the steel plate placed on the top of sand. In order to lower the centering, the plug is taken out due to which the sand flows out and lowers the prop gradually. Here you will get a clear idea from this image of this sandbox method. So, with this we have completed even the construction of arches. I hope you understand technical terms as well as construction of arches in detail. Thank you for watching. See you soon in the next lecture.